Classification of metals, conductors and semiconductors. On the basis of the relative values of electrical conductivity, sigma, or resistivity, ρ equals 1 by sigma, the solids are broadly classified as metals. They possess very low resistivity, or high conductivity. Rho similar 10 raised to minus 2 to 10 raised to minus 8, or mem. Sigma similar 10 raised to 2 to 10 raised to 8, s, m raised to minus 1. Insulators, they have high resistivity, or low conductivity. Rho similar 10 raised to 11, to 10 raised to 19, omega m, sigma similar 10 raised to minus 11, to 10 raised to minus 19, s, m raised to minus 1. Semiconductors, they have resistivity or conductivity, intermediate to metals and insulators. Rho similar 10 raised. Different types of semiconductors. Examples. Most of the currently available semiconductor devices are based on elemental semiconductors Si or Ge, and compound inorganic semiconductors. Classification on the basis of energy bands. Each electron will have a different energy level. These different energy levels, with continuous energy variation form, what are called energy bands. The energy band, which includes the energy levels of the valence electrons, is called the valence band. The energy band above the valence band is called the conduction band. Extrinsic semiconductor. When a small amount of a suitable impurity is added to the pure semiconductor, the conductivity of the semiconductor is increased manifold. The deliberate addition of a desirable impurity is called doping, and the impurity atoms are called dopants. Such a material is also called a doped semiconductor. N-type semiconductor. With proper level of doping, the number of conduction electrons can be made much larger than the number of holes. Hence, in an extrinsic semiconductor, doped with pentavalent impurity, electrons become the majority carriers and holes the minority carriers. Electrons move from the negative to the positive side. These semiconductors are, therefore, known as N-type semiconductors. P-type semiconductor. This is obtained when silicon or germanium is doped with a trivalent impurity like aluminum, and, therefore, this atom can form covalent bonds with neighboring 3 silicon atoms, but does not have any electron to offer to the 4th silicon atom. The dopant atom of p-type material can be treated as core of 1 negative charge, along with its associated hole. P-N junction. Consider a thin p-type silicon semiconductor wafer. By adding a small quantity of pentavalent impurity, part of the p-type silicon wafer can be converted into n-type silicon. The wafer now contains p region and n region and a metallurgical junction between p and n region. During the formation of p-n junction, and due to the concentration gradient across p and n sides, holes diffuse from p side to n side, and electrons diffuse from n side to p side. This motion of charge carriers gives rise to diffusion current across the junction. As the holes continue to diffuse, a layer of negative charge on the p side of the junction is developed. And holes taking part in the initial movement across the junction depleted the region of its free charges. General characteristics of solid state. The general characteristic of solid state can be described as follows. 1. They have definite mass, volume and shape. 2. Intermolecular distances are short. 3. Intermolecular forces are strong. 4. Their constituent particles, atoms, molecules or ions, have fixed positions and can only oscillate about their mean positions. 5. They are incompressible and rigid. Amorphous solids. Characteristics of amorphous solids. They are irregular shape. They gradually soften over a range of temperature. When cut with a sharp-edged tool, they cut into two pieces with irregular surfaces. They do not have definite heat of fusion. They are isotropic in nature. They are pseudo-solids or supercooled liquids. Arrangement of constituent particles are of short-range order. Glass, rubber and plastic are some of the examples. Crystalline solids. Characteristics of crystalline solids. They have definite characteristic geometrical shape. When cut with a sharp-edged tool, they split into two pieces, and the newly generated surfaces are plain and smooth. They have a definite and characteristic heat of fusion. They melt at a sharp and characteristic temperature. They are anisotropic in nature. They are true solids. They have long-range order. Examples are sodium chloride, diamond, solid iodine, gold, quartz, etc. Classification of crystalline solids, molecular solids, ionic solids, metallic solids, covalent or network solids. Molecules are the constituent particles of molecular solids. They are further divided into three categories. 1. Nonpolar molecular solids. 2. Polar molecular solids. 3. Hydrogen-bonded molecular solids. They comprise of either atoms, for example, helium, neon, argon, krypton and xenon, or the molecules formed by nonpolar covalent bonds, for example H2. In these solids, the atoms or molecules are held by weak dispersion forces, or London forces. They have low melting points, and are usually in liquid or gaseous state at room temperature and pressure. Pathogens. A wide range of organisms, belonging to bacteria, viruses, fungi, and parasites, could cause diseases in man. Such disease cause all parasites are therefore pathogens, as they cause harm to the host, by living in, or on, them. The pathogens can enter our body by various means, multiply, and interfere with normal vital activities, resulting in morphological and functional damage. Common diseases in humans. Typhoid. Salmonella typhi is a pathogenic bacterium, which causes typhoid fever in human beings. These pathogens generally enter the small intestine, through food and water contaminated with them, and migrate to other organs through blood. Sustained high fever, 39 degrees to 40 degrees Celsius, weakness, stomach pain, constipation, headache and loss of appetite are some of the common symptoms of this disease. Pneumonia. Bacteria like Streptococcus pneumonia and Haemophilus influenzae are responsible for the disease pneumonia in humans, which infects the alveoli, air-filled sacs, of the lungs. As a result of the infection, the alveoli get filled with fluid, leading to severe problems in respiration. The symptoms of pneumonia include fever, chills, cough, and headache. In severe cases, the lips and fingernails may turn gray to bluish in color. A healthy person acquires the infection by inhaling the droplets or aerosols released by an infected person. Or even by sharing glasses and utensils with an infected person. Immune system in the body. Skin is the primary barrier in the immune system. The human immune system consists of lymphoid organs, tissues, cells, and soluble molecules, like antibodies. The primary lymphoid organs are bone marrow and thymus, where immature lymphocytes differentiate into antigen-sensitive lymphocytes. The bone marrow is the main lymphoid organ, where all blood cells, including lymphocytes, are produced. Thymus is another lymphoid organ. Adjective phrase. Ali was a wealthy man. Here a single word is describing the person Ali. Ali was a man of great wealth. Here a group of words are describing the person Ali. A phrase which does the work of an adjective is an adjective phrase. Position of adjective phrase. An adjective phrase must be placed close to the nouns they describe. Otherwise, the meaning of the sentence changes. Examples. I borrowed a car from Iman with new tires. The adjective phrase describes the noun car, but since it is placed after the noun Iman, it appears that Iman is with new tires. So, we need to place adjective phrase close to the noun it describes, such as I borrowed a car with new tires from Iman.